types of parallelograms in this particular lesson. The first we're going to look at is a rhombus. A rhombus is just a quadrilateral with 4 congruent sides. Rhombuses are also parallelograms. A rectangle is a quadrilateral with 4 congruent angles. And a square is a quadrilateral with 4 congruent sides and 4 congruent angles. So if you look at how we'll see formal pictures of each of these. So a rhombus can be drawn like this. And we'll note that all sides are congruent. A rectangle drawn like this with 4 congruent angles. So if a quadrilateral has 4 congruent angles, what is the measure of each angle? 90 degrees, right? 360 is the sum of all the internal angles. 360 divided by 4, 90. The 4 congruent angles means all angles measure 90 degrees. And then we can draw a square like this. 4 congruent angles and 4 congruent sides. So it turns out each of these shapes, rhombuses, rectangles, and squares, they're all parallelograms, meaning they have all of the same properties that a parallelogram has, meaning opposite sides are congruent. Diagonals bisect each other. Consecutive angles are supplementary. Oh, and then opposite angles are congruent as well. In addition to those properties, right, we have a few others. But first, right, so all rhombuses are parallelograms. All rectangles are parallelograms by definition. But squares are also rhombuses. Squares are also rectangles. And squares are parallelograms. So all the properties that squares have, all the properties rhombuses have, squares have. All the properties rectangles have, squares have as well. All right, so let's look at this. A parallelogram is a rhombus if and only if its diagonals are perpendicular. So this also applies to squares. Since squares are rhombuses, so also work with squares. And a parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. So that means these angles are congruent, these angles are congruent, those two are congruent. So the diagonals make a set of 4 congruent angles. Okay, what do we know? Since a square is a rhombus, this also applies to squares. Okay? In a square, though, the diagonals make a specific type. These are all 45 degree angles for squares. Since it cuts the 90-degree angles in half. And then a parallelogram is a rectangle if and only if its diagonals are congruent. Also squares. The diagonals are congruent. So for the next example, on that next page, I want you to decide whether the statements apply to only parallelograms, rhombuses, squares, rectangles, or all of them. So take a few minutes. Go ahead and try that. All right, let's see how we did. So, it is equilateral. So this is for rhombuses. Squares. So the plural of rhombuses can the plural of rhombus can be done as rhombus is or rhomba. Whatever you want. Both work. Opposite sides are congruent. That's all of them. If it's a property of a parallelogram, then it applies to all of them. Diagonals bisect each other. All is well. Diagonals are perpendicular. That is rhombi and squares. And then is equiangular, squares and rectangles. Why is it B? B? Diagonals are not perpendicular. All right, so example 2. Use these properties to solve for the value of the variable. So just go through 4, or A, B, C, and D, and then we'll do the last example 3 together. All right, so this is a square. So I know this is a 90-degree angle. 90-degree angles measured, or right angles measured 90 degrees. Let's set that equal to 90 and solve. Subtract 10. 4x equals 80. X equals 20. So this is a rectangle, so opposite sides are congruent. 3x plus 4 equals 25. Subtract 4 from both sides. 3x equals 21. X equals 7. This one, diagonals bisect each other. So x squared plus 11 equals 36. Subtract 11. X squared equals 25. X equals positive or negative 5. The negative solution also works there. And then consecutive angles are supplemented. So x equals 65. All right. So I'm allowing you to use all of your note packet on this exam. And this is a hint. You might want to star this one. Something very similar to this will be on the test. So let's go ahead and draw a picture of a rhombus. And let's explore some of the properties and how we can solve this. So a rhombus. So a rhombus has 4 congruent sides. I'm given the length of the diagonal. So I'm given the short diagonal is 12, and then the long diagonal is 16. All right, so what do I know about the diagonals of a rhombus, which is also a parallelogram? Well, first, I know that they bisect each other. So if this whole side is 12, if this whole length is 12, this is 6, that's 6. If this diagonal is 16, this is 8, and that is 8. The other property of rhombuses that I know is that the diagonals not only bisect themselves and the opposite angles, but the diagonals are perpendicular to each other. So my diagonals are perpendicular, meaning what type of triangles are created in here? Right triangles. So we have 4 congruent right triangles. And if I want to solve for one of these side lengths, which are all the same, I have a tool which I've used all year long. Right? The hypotenuse is my side length. And then I have sides of 6 and 8. I can use my good old buddy, old pal, the Pythagorean theorem, and solve for the missing side. So I get 36 plus 64. equals x squared. X squared equals 100. Square root x equals 10. We can ignore the negative solution in this particular case because it represents a side length, and the lengths are not represented by negative.